Hello everyone and welcome back. In this video we're going to begin talking about sampling interpolation. So Lee, what exactly does that mean?
Well, what we're going to be doing is looking at where we're sampling, where a vertex is in world space, and then we're going to figure out where that would correspond in a height map and get the height at that information. Now, we had mentioned in previous videos that the numbers that we're going to be getting for our vertexes aren't going to lie exactly at pixel locations on our height map. So what we need to do is figure out what a realistic height would be at that point in between pixels.
Okay.
We do that by interpolation. We had also said in the last video that we were going to start blending noise in and make our terrain look a little bit realistic. I kind of lied. We're not going to do that in this video. We will get to it, but I was looking at the sampling and the interpolation. I decided it'd be better if we just tackle that in its own video, and then we'll get the noise brought in an upcoming video.
That sounds good.
So what do I mean by interpolation and how does this work? If you could bring up Photoshop for me.
You bet. There we go.
All right. What I've done is started off with this little whiteboard thing.
Hey, Zach has signed in. Do you want to go ahead and close that out? Do you want to bring up a new layer?
If you could for me. I was trying to get my mouse back over there. So just hit new layer. All right. Now, if we were to imagine that each one of these white squares was a pixel on or inside of a height map, yeah, normally they would be lined one up next to each other and you wouldn't have this large area in between them. But I put this large area here so I could demonstrate what happens. When we have a vertex and we do all of our calculations, we may very well end up with a vertex that goes, no, I'm a point that is right at this spot right here. And if I fill this in with white, so what we end up with is this point might not lie directly on this pixel or directly on this one or any one of these. It's right in the middle of all of these pixels. And this point could literally be anywhere inside of this area. What we need to do is come up with a way that we can calculate an accurate height at this point in space on the height map. And that's what we're going to do in this video.
Okay.
So to do that, let's jump over to Visual Studio, go into our train generator, and we're going to make a new class. This is just going to be a private. It's going to return a float, and we're going to call this sample base map. And now we need to be able to take in a float for X, a float for Z, and a float for our scale.
Go ahead and take out that
Yeah, I'm
backslash.
going to in a sec. I saw it as soon as I hit enter. So the very first thing we're going to do is set up a field to hold our height, and we're going to return that height. So right off the bat, it's going to return 0 if we don't do anything other than that. I also want to come over here to get height, and I'm going to change our functionality here right off the bat as well. So what I'm going to do is I'm going to take this line of code, I'm going to copy it, put it down here for now because we're going to have to pull this apart here in a sec, and we're just going to tell our height to sample our base map height. We're going to pass in X, Z, and our scale. Now, here, we're going to need to keep track of a couple of things besides just height. I want to have a variable for our map. Well, let's start with map width. So we'll have our map width, which is going to equal our base map width Actually, I can probably type that faster than copying and pasting it. Do the same thing with map height. And then I want to be able to set up our offsets here as well. So and we could do a lot of this inline. I just want to break it out as much as possible because the math here is well, not complex, gets kind of involved. And having nice names for everything will make it a little bit easier to read. All right, so that gets me all the stuff from here. So I'm not going to need this anymore. Now, what we want to accomplish at the end of it is to get a piece of information for our height, and that height is going to be from our height map. So once everything is all done, we're going to have a value for height. Now, how do we get that height? Well, to get that height, we have to do a whole bunch of calculations. We know that we're passing in an x and a z, and these are floats, so they're going to be between a whole number. And we need to figure out and separate that whole number part of the float from its fractional part of that number. So to do that, we have to get the floor and ceiling part of that number. But even before we do that, we have to apply scaling and offsets to get our true x and y before we start doing interpolation. So we need to get our scaled x, and that's going to be the x that we pass in multiplied by our scale plus our half map width. So this gives us a scaled version plus offset. So this will be what we're going to be calculating off. This is still going to end up being a float. And we need to do the same thing with our z. So we'll have a scaled z value. This will be z times scale plus our half map height. So now we've got a corrected x and z location that we can break apart and get the floor, or basically the lower half of its number. If I jump back into Photoshop real quick, what I mean by the floor is if this is our point that we're looking at, we need to interpolate between these values that surround it. So our floor of our x in this particular case would be 0, while the ceiling would be our 1. And the floor for z in this case would be 0, and the ceiling would be 1. And we're trying to get all of this information back out. So we're going to break all of this into individual components. Jump back into code. So we want to start off with finding the floor of x. So we'll look for fx, which will be the floor of x. To do that, we're looking for the integer. So we'll get math f dot floor, and we're going to pass in our float. What we're going to pass in is going to be the scaled x value. And then we do the same thing for z. Now the nice thing is, because we're using the get pixel functionality, we don't have to deal with wrapping. so we don't have to take the modulus and figure out where we are and if we're outside of the dimensions of the height map wrapping, which is something that once we start experimenting with threading, we're no longer allowed to use those API calls. We will have to deal with the wrapping on our own. But luckily for now, we don't have to. So we need to get the floor of our z value. So we're going to get the scaled z. We need the ceiling of our x, which is going to be the integer of mathf. And let's get the ceil. Actually, there's a ceil to integer. I forgot about that. We could use that one too. Save us some time. And I think floor has the same thing. Now, I'm trying to make changes on the fly with my notes because my notes take threading into consideration, which I don't have to deal with.
I got you.
So that's why I'm trying to, or my code looks a little bit different right now than it used to. Yeah, there we go. Which means I can get rid of this. And give me a sec while I copy and paste this stuff. We're looking for the ceiling of the z value. So that gives us our 4 numbers that we need to construct our points. Now, we need to construct the points. So we're going to get our height at our first one, which is going to be our base map dot get pixel. And we can take the floor of x and the floor of y. Floor of z. Sorry about that. And we duplicate this 3 more times. So H2, 3, and 4. Now, our second one, we want the ceiling of x and the floor of z. Then we want the floor of x, but the ceiling of z. And then finally, both the ceiling of x and the ceiling of z. So what we've done, get Photoshop back up, is this is the floor of x and floor of z. This is the floor of z with the ceiling of x. This is the floor of x and the ceiling of z. And this is the ceiling of both of them. So what we've done is H1 is this one, H2 is this one, H3 is this point, and H4 is this point. So we've just gotten those 4 pieces of information. Now what we need to do is interpolate in such a way that we come up with a value that would be this point.
Okay.
So
Is that your alarm?
That was my alarm saying it was, midnight now,
Midnight,
I guess?
yeah.
So I'm halfway through the workday. I'm doing good. I forgot about that. I don't even know where it is. Well, it's on my watch, but you've seen my desk.
Right.
So
Means you may never see that watch again.
I really, really hope I do see it again because that particular watch is my dive computer.
Oh, yeah.
And I do hope I see that again sometime. So, all right, let's get back into code. Can you bring that up? It won't let me anymore.
There you go.
Thank you. All right, so now we need to interpolate or blend between our points that we've got. So we're going to start off with B1. This is going to be our first blend. What we're going to do, again, like I showed you in the last video where we started taking the using lerp instead of averaging. So we're going to take the lerp, and we need to go ahead and lerp between H1 and H2. And we need to do this by an amount. For now, I'm going to set 0.5, and we'll come back and I'll explain why this is not going to work for us here in a sec. I also want to see why this is giving me an error. Some multi-parameter type float. H1. Oh, my bad. These are returning colors. I need to sample just the red channel. Forgot to do that. So now it should be happy. So now the second blend is going to be a blend between H3 and H4. So what I've done is I've taken the first numbers. Again, let's get on the right screen. And I'm right now hard coding it to take halfway between these two numbers and halfway between these two numbers, which kind of gets us there, but not all the way yet. So back into code. Also, we definitely aren't going to be halfway all the time, so we have to come up with some way of knowing how far off are we. To do that, we're going to need a ratio. So we're going to bring up a ratio. This one I'll call Rx. This is going to be our scaled x minus the integer of scaled x. And we need to do the same thing for z. So what we're doing is we're removing the whole number component from our scaled values to get just the fractional part. And we're using that fractional part to drive our lerps here to determine how far we're going to wait between each of our two sample points. So this very first one is going to drive or be driven by our ratio between x, and our second one is also going to be driven by the ratio between x. So Rx is going to dictate how far between these two numbers and these two numbers are we going to blend. In this case, we're about 75%, so Rx is probably going to be, or will be, roughly about 0.75. Now, that gets us into this ballpark, but we don't have anything up in the blend between this number and this number are derived between the blends. So that's what we need to do now. To get that number,
Does it not want to come back up again?
no, I was on the wrong one.
Oh, I got
We
you.
need to do a final interpolation between the two. And this is going to be our final height that we're going to end up with. So that's going to be our height is going to equal the lerp. So we'll bring up mathf again. Linear interpolation. And we're going to lerp between the values of B1 and B2 by the ratio returned by Z or Z. So this will get us that last bit of the way. So we're now going to take the number that we got from here, or the blend between these two, and then we're going to take those numbers and we're going to blend in between the two, which gives us this number right here. It's not exact. This is interpolation. It's an approximation, but it should be close enough for what we're doing so you won't notice, because we don't really have data at that point. Now back to code. Open that up, build, make sure everything's fine. Everything should work. We can go ahead and give it a run and see what happens.
Alrighty.
Go ahead. Okay, great. So it's working. Everything's flat. It's doing exactly what it's supposed to do. Now, we've got a small problem. We had altitude before. We don't have it anymore. It's because we're taking our output and we still have to multiply it by our max height. Now if we try it, our character's falling. That's a plus. But as you can see, we don't have those real nasty stair steps that we had before. We're starting to get closer to something that looks like a train. We have a slope with some contour to it.
That we do.
So we're starting to get there. Still nowhere close to where we'd like to be, though. So to solve that, we need to start sampling from the noise map.
Okay, and that we
that
can
will
go
be the
ahead.
topic of the next video.
Yeah. All right. So is that everything you wanted to cover in this one?
Yes.
All right. Well, that will wrap up this video. Thanks a lot.